This is not a distant warning. This is happening right now. California's coastline is breaking apart. Roads are cracking, rail lines are shifting, and massive cliffs are collapsing into the ocean. What once took decades is now unfolding in days. Storm after storm, wave after wave, the edge of California is giving way. And the most dangerous part, much of this collapse happens without warning. California's coastline has always been in motion. For thousands of years, waves, tides, and storms have slowly carved its cliffs. But what is happening now is not slow, and it is not normal. Across the state, roads that once felt permanent are cracking apart. Rail lines built along scenic bluffs are bending and shifting. Entire sections of cliff are collapsing into the ocean below, sometimes without warning, sometimes one after another in rapid succession. These are not isolated incidents. They are not the result of a single storm or a rare event. What we are seeing is a system under constant pressure. Multiple stretches of coastline are failing within days of each other, forcing scientists, engineers, and emergency planners to pay close attention. The concern is growing because the forces acting on California's coast are no longer arriving one at a time. They are stacking up. Relentless storms have saturated the land. Ocean levels are higher than normal. The ground along the coast remains waterlogged and heavy. Together, these conditions are pushing already fragile landscapes toward a breaking point. For millions of people who live, work, or travel along the edge of the Pacific, the question is no longer if the coastline will change. The real question is how fast and how suddenly. In a typical winter, storms arrive in cycles. Rain falls, rivers swell, and then conditions ease, allowing the ground to drain and regain strength. This winter, that reset never came. Storm after storm swept across California with little time to recover in between. Each system added more water to cliffs and slopes that were already saturated. Instead of drying out, the land stayed heavy, weakened by moisture that seeped deep into rock and soil. At the same time, the Pacific Ocean delivered powerful long-period waves generated by distant storms. These waves carry enormous energy. When they reach the coast, they do not fade quickly. They strike the shoreline again and again, focusing their force at the base of coastal cliffs. Elevated tides make the damage worse. Higher water levels allow waves to reach parts of the bluff that are normally protected, attacking stability from below while rain weakens it from above. Scientists describe this as a compounding effect. Rain increases weight and reduces strength. Waves remove support at the base. Higher tides raise the impact zone. When these forces overlap repeatedly, collapse becomes far more likely. Many of California's coastal cliffs appear solid and immovable, but beneath the surface, they are often built from unstable materials. Large sections of the coastline are made of layered sedimentary rock, sandstone, siltstone, and mudstone, stacked unevenly over time. Thin seams of clay between these layers can act like lubricated surfaces when wet, allowing entire sections to slide. As waves carve into the base of the cliff, they create hidden voids that undermine support. Over time, the upper portions begin to jut outward, held together more by friction than by strength. Rainwater accelerates this process, adding weight and reducing resistance between layers. Eventually, gravity wins. Blocks of earth and rock detach and collapse toward the beach below. High-resolution geological mapping shows that many of these bluffs are already fractured and actively eroding. Under prolonged stress, collapse is not unusual. It is how these landscapes fail. Certain areas of California's coast are now under constant surveillance because the risk is ongoing. In Southern California, cliffs near Del Mar support a major rail corridor used by commuters and freight. Years of cracking, slumping, and small collapses have forced repeated repairs and service shutdowns. Engineers monitor this area closely because even minor movement can create serious danger. Farther north, the Portuguese Bend landslide on the Palos Verdes Peninsula represents instability on a much larger scale. Covering hundreds of acres, it is one of the largest active landslides in the United States. Movement here never fully stops. Roads warp, utility lines strain, and freshly repaired pavement cracks again. Entire neighborhoods sit on land that is slowly, and sometimes suddenly, on the move. Monitoring a moving coastline requires multiple technologies. Airborne laser scanning creates detailed maps that reveal subtle changes in shape and elevation. Satellites track ground movement across wide areas, detecting shifts too small to see with the human eye. Ground-based GPS stations measure movement in real time, while sensors embedded in the soil track tilt, pressure, and subsurface motion. These systems provide critical warnings, but they cannot predict exact moments of failure. Monitoring reduces uncertainty. It does not eliminate it. When data shows accelerating movement, authorities must act quickly. Roads may be closed. Rail service may be suspended. Utilities prepare to shut off water, gas, or power if the ground begins to pull apart. In residential areas, homes can be declared unsafe with little notice, forcing families to evacuate. These decisions carry real consequences. Long detours, disrupted emergency routes, economic losses, and displaced communities. But officials stress that even a few centimeters of movement can mean the difference between stability and sudden collapse. If storms ease and dry weather returns, some slopes may slowly regain strength. Transportation routes may reopen temporarily. But erosion never truly stops. And if storms continue, risk will rise with each new surge of rain and surf. The most dangerous moments come when heavy rainfall, elevated tides, and powerful waves arrive together. In those conditions, cliffs can fail without warning. Past tragedies prove this danger is real. Fatal collapses have occurred on calm days, triggered not by a single event, but by years of gradual weakening. Today, more people than ever live and work near the edge. As storms grow more frequent and sea levels rise, the margin for error is shrinking. California's coastline is no longer a fixed line. It is a shifting boundary shaped by accelerating forces. The land is moving, with or without permission. Every tide redraws the edge. What happens next will define the future of life along California's coast.